Hello, my name is Rob Webb. I'm a product specialist for IDS in the UK and will present this next session. We heard from Steve in the previous session about the general ethos and overview of IDS NXT Ocean. In this section, we will work through an example to see how straightforward it can be to build a solution with NXT Ocean. And in this case, we will build a classifier for detecting eyes or sprouting on potatoes. And since we're in lockdown, I had to raid my vegetable drawer to find something suitable, and fortunately had a few spuds that were just starting to sprout, so we have something that I hope is deemed representative of some possible applications. The process will be based around our tagline for NXT, and that's grab, label, train, run AI. And just a quick note, we will have more in-depth versions of this process in a series of videos available on our website and YouTube channel, which will cover areas that we will necessarily skim over today for the sake of brevity. The first thing we need to do then is to grab our image data. Now, in principle, this can be image data that already exists. It's not uncommon for producers and manufacturers to have large databases of images already, and it is possible to use these datasets. However, our recommendation is to use the same hardware and setup for the training images as will be used for the application. But the use of other datasets can still be evaluated by following the same steps we will see after this section for grabbing images. We start then by running the IDS NXT Cockpit application that provides the control and configuration of our NXT camera. From here, we select the camera and log in and navigate to the Vision Apps section where we can see all of the Vision Apps that are supplied with the camera. To acquire and save image data for the training datasets, we'll select and use the Crawler Vision app. And there's also a corresponding crawler app that runs on the host PC that we've already set up. We don't need to dwell on this at the moment, but essentially this creates a data streaming link between the camera and our local PC where the training images will be stored. We can now go into the Vision Apps section and select the Camera tab to set up our camera and optimize the images. So this includes adjustment of exposure and gain, white balancing, any image rotation and flipping, and any triggered control. We need to set the class name for the images. In this example, we will have two classes, one for all of the images with sprouting and eyes, and one for all of the other images which will be labeled OK. Now we can acquire a number of images of each class, and the class label will ensure these are streamed to separate folders on the host PC. And we can change these labels later, so there's no need to worry about this too much at this stage. It just needs to be sufficient for you to tell them apart later on. As we acquire each image, we can see the counter below the image display increments, so we can see how many images in total we have acquired. And for some applications, the total number of images per class may only need to be perhaps 50, and for others it may need to be in the hundreds. And this depends largely on the complexity of the task and the variation in the classes. As a start, we can quickly evaluate the likely success of a project with a few tens of images per class, as we'll do here. And a couple of operational notes here. Firstly, you'll see that we are acquiring just the relevant regions of the image rather than complete images. And this is required for the image classification training sets, and we'll see a bit more why in the next section. Also, the camera is set up with a software trigger, and this ensures that we only send a single image of each sample rather than continually streaming the same images over and over again. When we have enough images, we can stop the Crawler Vision app running and move to the next step of labeling our images. So we turn to the NXT Lighthouse cloud-based AI training software for this, and we'll start by creating our dataset by clicking the big plus icon. And we give the dataset a name, potato classifier, and a description, images of potatoes with and without sprouts. And we can also add a thumbnail image for easier identification later. We then need to add the image data, so we click Add Folders and then add and navigate to the folder of images on our PC and click Upload. We then see a preview of all of the images, and by default the subfolder names are used to provide the labels for our images, or we can add new labels or edit existing labels later if required. Finally, click Upload and the images are then uploaded to NXT Lighthouse. Here we have a preview of the images that we have uploaded, and we have some statistics to see the number of images in each class, and we can click on each class label and filter them out so that we can just see one class and check for any mislabeled data, for example. And there's something Martian-esque about these images, I think. If we were using the object detection method, we would have acquired firstly the full images rather than subregions, and then we click on the images and now draw bounding boxes around each of the features. So you can see why I chose classification in this case. It's just a quicker process for demonstration. On the right hand side under annotations, that's where we can edit the label names if we so wish. Now we have our data sets, we need to create our project to train the neural network. On the project section, we again click the big plus button to create a new project. And first we must choose between the two available methods, classification and detection. And as I mentioned, we're working with classification, and just as a side note, both methods have their use cases depending on things like the processing time requirements, the presentation of the objects, and the required results ultimately. And we can advise on this for your applications. Next, we add the details about the project, and we also have the option to enter an email address. Since the training process can take anything from a few minutes to several hours, depending on the size of the data set and the type of neural network we use, Lighthouse will send an email on completion of the training, so you can go about your daily business and come back to this when it's ready. The next action is to select the dataset to train from. So here we can see the available datasets, and in particular the one that we've just created. And we can also select the utilization. And this is the split of images that we will use for the training and for the validation. A 70-30 split is the default and the recommended value, but other splits are available. With our dataset chosen, we then move into the training section. And here we just have a couple of things to configure. Firstly, the data augmentation. Now this is a method to increase the number of images in the dataset by randomly augmenting the data through image flips, rotations and other transformations, and this helps with the generalization of the neural network when it's working on new image data. And then finally we choose the inference time or the decision time. Now what this needs to be is basically a balance between the time required for a result by the system and the accuracy required for a system to function well. And we have the option to select between 13 milliseconds up to 75 milliseconds for that decision time. We recommend building multiple neural networks with different inference times so you can then compare the performance later. Then we click on the Train Neural Network button and let the software get to work. Whilst we watch the training process, and this is accelerated by the way, this gives me the opportunity to mention a couple of things. So firstly, when using classification, we can use a single search area or we can use a multi-search area. And with multi-search regions, the inference time is multiplied by the number of regions. So if we have 10 regions configured with the 13 millisecond inference time, this will produce a total inference time of around 130 milliseconds per image. If using the object detection, we don't have the option to choose an inference time. This is fixed at 131 milliseconds. However, this is always the total time, regardless of how many objects are detected in the image or the size of the image. So now our neural network is built, we can see quickly how successful the training was by reviewing the graph. And if we are happy with the results, and these look pretty good, we just need to download the CNN, give it a name, and then switch back to NXT Cockpit software to upload the neural network to our camera. Now we get to run our AI. And to do this, we log back into the camera in NXT Cockpit and navigate to the VApp Manager and start our classifier VApp. We need to install the CNN, so navigate to the folder in which we downloaded the file from NXT Lighthouse, select that CNN and click Open. After a few seconds, a message is displayed notifying you that the upload was successful, and then we can select our newly uploaded CNN in the drop-down list and start using it. With classification, we start with a single region, and we can move this around the screen manually to test the results, and we can see the classification result underneath the main image window, or if the neural network was trained on the full image, we can classify the complete image. We can also enable the multi-region search by setting our first region size and position and clicking Add Current ROI under the Actions section, and then repeat this process to build up the multi-ROI search. If we then click on the result image, we can see the classification for each region. You can also upload a list of preset positions by clicking the upload arrow next to ROI settings, and this makes it easier to get the ROIs nicely aligned. The regions that contain the sprouting produce a positive identification, and we see OK in the other regions. And there's some good high confidence scores there. We can also have a quick look at the object detector. So we disable the classifier vision app and enable the object detector vision app. And if we need to upload the new neural network, we follow the same procedure as we did for the classifier. Here we already have the CNN installed and enabled on the drop-down list. So we just need to click on the ROI thumbnail image at the bottom of the screen and we see the results of the object detection. We don't need to define where the neural network is processing. It determines where in the image any of the trained classes are found, along with the confidence score and a bounding box around the object. In this case, because of the relatively small number of images used and a reasonably high variation in the trained cases, it is struggling a little to reliably set bounding boxes. However, we are at least detecting the presence of the sprouting, so we can have some good confidence that the application is applicable for artificial intelligence. And to improve the results, we just need to add more images into the data sets and repeat the training process. We can also adjust the detection threshold in order to filter out false positives, or to ensure we detect even the lower confidence matches, we can drop the threshold down. So with just the out-of-the-box elements of NXT Ocean, it is possible to produce a simple test system which can be used for monitoring products on or offline with AI processing. And importantly, without any requirement to learn or understand neural networks. Of course, it always helps to have some knowledge on the subject, especially to ensure and achieve the best results. And we will be offering more information through our IDS Vision channel, our YouTube channel, and application guides and white papers available on our website. And this will include things like best practices for building a dataset, guides to external interfacing to expand the system functionality, and information on other VApps available with NXT Ocean. And of course, we are available to discuss and advise on applications you may have. Thank you very much.